The last few weeks I've seen some textbook examples of what are informally called meteorological bombs, mid-latitude lows that strengthen very rapidly by at least 24 millibars in 24 hours. That's about 7/10 of an inch of mercury in a day. Those of you who check your barometers a lot know that's a very impressive pressure drop. Now there's two ways to think about lowering the pressure in a column of air. One is a temperature approach. You warm the column, which makes the air less dense and lighter. In hurricanes, the strongest lows on Earth, this occurs as some of the rising air in the thunderstorms that surround the eye sinks back into the center and warms. In extratropical lows, the ones that typically affect us, the warming comes mostly from warm advection, which simply means that the wind moves warmer air into the column. And typically this happens fairly close to the surface, but when lows rapidly deepen, it often occurs around jet stream level, where relatively warm air from the stratosphere can be drawn into the column. Warming can also occur from below if, for example, air flows over relatively warm water, as commonly happens in winter as cold air pours off continents and out over the ocean. In fact, the lowest pressures ever observed in extratropical lows are over the North Atlantic and North Pacific Oceans in winter, as bitterly cold air coming off North America and Asia is modified by the relatively warm water below. A second way to think about lowering air pressure is simply by removing mass from the column. Now, winds near the surface converge toward the center of a low, which adds weight, so you need the opposite at high altitudes. Winds must diverge and take more air out than is being added by the converging surface winds. Whether it's this mechanism that lowers the pressure or warming the column by advection or heating, these processes work best in the mid-latitudes in winter, because that's when temperature contrasts are largest, and temperature contrasts create pressure differences which make the wind blow. And fast winds move air around very efficiently. In the last few weeks, I've seen two classic examples of lows deepening rapidly over the ocean. Here's a storm south of Japan on January 14th, analyzed at 980 millibars by the Ocean Prediction Center. A day later, it had deepened to 932 millibars and looked like this from space, dominating the North Pacific Ocean. Then in late January in the North Atlantic, a storm that had dumped up to 6 inches of snow in Maryland on January 24th put on a similar burst of intensification, its central pressure dropping 54 millibars in 24 hours to 930 millibars, a pressure typical of a Category 4 hurricane. In fact, if we don't count hurricanes and tornadoes, the lowest sea level pressures on Earth occur in extratropical cyclones in the North Atlantic Ocean. Here are the lowest of the low as measured by unfortunate ships that got in the way. These pressures correspond to about 27 inches of mercury off the scales on most home barometers. Coming up next, we'll let you know if any rapidly deepening low pressure systems are in our future in the extended forecast.